All right, welcome. Today we're going to be working on merge intervals. This is a pretty frequent problem that you can see in most of the, you know, big five, big six, big seven interviews. I've had it a few times interviewing for Amazon and Google. So we'll get started. We're going to use Java today because guess what? I am. If you want me to do anything else like Python or Ruby or COBOL, maybe. Let's go. Given an array of intervals where the intervals containing two elements have a start and an end time, merge all the overlapping intervals and return an array of non-overlapping intervals. So, for example, you get given this set of intervals: start time 1, 3, start time 2, 6, 1 and 3, end time of 3 is greater than the start time of the second. So these would merge. 8 and 10 is compared to 6 is good to go. So that would get added. And 15 and 18, the end time of this element is less than the start time of this, so that would get added. So your output is 1 and 6 since we merge this, 8 and 10, 15 and 8. And here, 1 and 4, 4 and 5, you would output 5. Now, one thing you want to do when you're doing interviews is when the interviewer gives you a problem, they're gonna kind of wait for you to ask for edge cases and constraints if they don't give them. That's a reason of thinking when you're developing. You want to consider that. And generally, you should address those first in the code, or potentially write a test to account for that if you have extra time. So we know that the interval's length is always going to contain two elements. And if you look here, it can go to 10 to the power 4. So that what that means is you want to be space and memory conscious. Um, so when you're thinking about how to solve this, there's a few ways you could go about it. Considering we're already being given a double array, one idea and approach you could use is a hash set. But when you're looking at this and being conscious of space and memory, a hash set's not really necessarily the best way we could go about this. So first off, let's get started. We're gonna sort the intervals based off their start time. I like to do small variables like this just to improve readability of code. And we're using a lambda expression to sort this. And the lambda expression takes a custom comparator, which is what I'm writing. It's basically a functional Java method. And it needs to know, hey, since you're giving me a double array, what am I supposed to compare out of these? You could potentially only want it to compare one, a different value, maybe the second value. So we're going to go here. So what this does is it sorts intervals via lambda expression. So you give it two different arrays here. It's going to compare. It'll do an integer compare on the first element of array A and the first element of array B. If array A is less than B, it'll return -1 and sort it least to greatest. If it's equal, it returns 0, it keeps it there. And if it's greater than B, it'll return 1 and move it towards the outside of the sort. Just for clarity. Let a comment for readability. Okay, so now that we've sorted them, we need to have a return variable. So we're going to do a list of int arrays, call this merge list. And we're going to use an array list. Now, I know when you're using a list, you could just use a linked list, but um, we're trying to be efficient. So an array list is better than a linked list because it has better access speed. You want to use a linked list when you have more frequent writes. Um, and edits. Um, so we'll also want to keep track of the last interval because we don't want to be calling a method in the array to get the last element. We just want to have a pointer to it. That's faster computation. So, okay. And we're going to go ahead and add that to our return variable. Let's go ahead and just really quickly write the return. So we're going to have to convert it, the list of int arrays, to a double array events. So we do that via to array, and we want to classify that we are doing a new int, double int array. So we need to specify the size. So we'll get that. And since it's a double array, don't forget the second set of brackets. I know that can look a little confusing, but let's get it right. So we've added the first element, and now we're going to iterate over the rest of the intervals here. And so what's interesting is um, since we're keeping track of the first interval and we've already added it, we're going to be starting the loop at 1 because that will save us speed. And the first thing we're going to do is get the current interval, get a pointer there. And then we want to check for overlap, or if there's no overlap there, that is. So if the current interval start time is greater than the last interval end time. So what this means is if we're starting here, this is our last interval, this is our current interval. If the current interval start time is greater than the last interval's end time, then we have no uh, override. So for instance, right here, current interval will be 15. Last interval's end time is 10. So the current interval start time is greater than, you can add it. Here is a bad example. This would be a merge. So if current interval start time is greater than the last interval's end time, then we know no overlap of time, add the new interval. And then update the last interval. Don't forget to do that, or your whole program will break. And so this covers the case if it is no overlap of time, we're just adding it. So the first one, and then moving on. But when we hit this case that's a merge, we need to accommodate that. So otherwise, we want to merge them. So what we'll do is the last interval. So for instance, we're right here in this example. Current, last. The last interval's end time is going to equal the max, and we're going to use the math.max function here for the last interval end time compared to the current interval n time. So what it'll be doing is it's assigning the n time of this last interval to the maximum of its n time here. Sorry, uh, the 3, or the n time here, the 6. Okay. And that should be it. Let's clean this up a little bit. Get rid of format. Oh, I don't even like that. Terrible. All right, let's run it and see what happens. It's accepted. And we did good. We beat 97.62% complexity. In the time, and the memory is beating 82%. So this is pretty good. And this is running in, I believe, of n log n. We can check. Yep, n log n. And then the memory complexity should be O of n. Yep. So basically, just to iterate over some of the things that we were talking about, is we want to make sure that we're using the right data structure to handle accesses and writes. If you need to do frequent accesses, an array list is going to be better than a linked list. We're sorting them all. We're sorting all the intervals based off their start times because that way we can easily compare them. If they're all out of order, it's going to be a cluster of pain, and you don't want that. It's just going to be hurting your brain. We're writing, simple variables to keep track of the indexes just to improve readability of code. And we're tracking the last interval and the current and assigning a current interval. That way we can avoid using any of the array list functions in order to get the last added element. For instance, you'd have to keep a counter. You can just do this. And we're checking to see the times, comparing them, adding, otherwise we're merging. I do want to note that you should be, whenever you see a problem that is, um, how do I clarify this? You want to use math.max. Because if you're not using math.max, then you're going to run into issues if you're trying to compare them. So it really is just if you see interval problems, a sliding window problem, you want to be adjusting the window with the math.max. You don't want to try to compare the values. So just hammer that in your head. If you try to compare the values, you'll run into weird issues and some use cases and edge cases. But we got it in, what is this? Ooh, over here, O of n log n for time, O of n. This is the merge intervals. Hope it helps out.